Today we're going to be talking about arithmetic and geometric sequences. Now when we're talking about sequences, of course we're talking about patterns, and there are two different ways that you can go about finding patterns of numbers. The first one we're going to talk about is called arithmetic sequences. I know it looks like arithmetic, but it is called arithmetic. For these, we are going to be talking about whether we're adding or subtracting in between numbers to get from one number to the next. That is called a common difference. When we're talking about common difference, we're going to use the letter D. So, in this first example, it says A sub 1. This is sub 1. A sub 1 equals 5. That's where we begin. That's the first number in the sequence. So A sub 1 is 5. The next number is 9. And then after that, 13. And then after that, 17. And then it goes on forever. That's what those little 3 dots mean at the end. So we're always trying to find what the next term is by figuring out the pattern in between the numbers before it. If you look here at 5 and 9, you notice that you add 4 to get from 5 to 9. If you look from 9 to 13, you're also adding 4. The same happens whenever you get from 13 to 17. So that would be a common difference of 4. So the next term is always found by adding the common difference or the same number in between the previous terms. Now let's look at an example of an arithmetic sequence by looking at example number 1. The easiest thing to do in order to figure out what the pattern is, to take it from this really formal language that they have right here and put it into a format that you would understand a little bit better. And that's by just rewriting it exactly as you see it. The first number, or A sub 1, is 3. The second number is 8. And then 13, and then 18. And then you're going to put a comma and an ellipses. That tells you that it keeps on going forever and ever until you decide to stop writing numbers, right? Now, our goal is to figure out what the sequence is between each numbers. What is the common difference? If you go from 3 to 8, by using adding or subtracting, we know that there's going to be plus 5. From 8 to 13, we're adding 5. From 13 to 18, we're adding 5. And if we were to keep on going, then we would get more numbers. In this instance, it's asking us what the next 3 terms are. But first, I want you to write yourself a note. This is an arithmetic sequence. And it is D of 5 because we are moving 5 times for each number. The next number that we're going to find in the sequence is to go from 18 plus 5 to get A sub 5. I'm going to write A sub 5 down here, and then I'm going to add 18 plus 5 and get 23. I'm going to do it again to get A sub 6, or my next location. And 23 plus 5 is 28. And then I'm going to do it one more time for the next term in the sequence, because 28 plus 5 is 33. You can keep going on and on and on forever, but it only asks us for 3, so we're going to stop right there. Now the next type of sequence that you could possibly have is called a geometric sequence. Geometric sequences can be found if you multiply or divide numbers to get to the next step. But what I want you to do is I want you to mark out divide, and I want you instead to say that you are going to multiply by a fraction. multiply by a fraction. Multiplying by a fraction is the same exact thing as dividing, but instead of saying a common difference, this time we're looking for a common ratio. And your ratio is the amount of times that you're going to multiply a number to get to the next one. We're going to represent that number with the letter R in parentheses. So the example that it provides is A sub 1, or your first number, as 5. Your second number is 15. Your third number is 45. And your fourth number is 135. We have to figure out what number can we multiply 5 by to get 15. Well, using my brain and my handy dandy calculator, I multiplied them together and I got 5 times 3 to get 15. Now I'm going to use this little dot because remember in algebra we use the dot instead of a times or an X, because it's very, very confusing when we put letters with numbers because we use variables in algebra. Now the next one I'm going to do is 15 times something equals 45. The first thing I'm going to check, because I need to make sure that it is a common difference, is 15 times 3. Well, 15 times 3 is 45, so I'm going to say that we're going to put this here. And 45 times 3 equals 135. So my common ratio is going to be 3. My common ratio is 3. I found 3 because I took the next term. I found the next term by multiplying the previous term by a common ratio, or the same number every single time. Now let's practice. Let's look at example number 3. It starts with A sub 1 is equal to 2. The easiest way to do this in my mind is to write it out the way that I see it written for me in the formal language into just regular numbers in a list. So I have 2, and then 4, and then 8, and then 16, and then I need to find at least 3 terms that come after that, but I have to figure out what we are multiplying the first number by to get the second number. I know already that it's geometric because it told me. So what number am I going to multiply by 2 to get 4? Well, 2 times 2 equals 4. Let's see if 4 times 2, let's see if 4 times 2 equals 8. 4 times 2 is 8, so I'm going to put that as my common ratio. And then I'm going to take that 8 and I'm going to multiply it by 2, and then I'm going to get 8 times 2 is 16. So in order to find the next 3 terms in my common ratio, I'm going to multiply each one by 2. So I have A of 5 equals 32, because 16 times 2 is 32. And then I'm going to go A of 6. 32 times 2 is 64. And for my last one, I'm going to say A of 7 is 128, because 64 times 2 is 168. Now we have 2 more examples. We have example number 2 and example number 4. I want you to pause the video right now and I want you to try each one. I'm going to go ahead and write out the numbers, and you decide whether it's arithmetic or it's geometric, and then you decide what the common difference or common ratio is. All right, now let's check our work. For example number 2, if you went ahead and wrote out 7, 1, -5, and -11, you should have found that this was an arithmetic sequence. To move from one number to the next, you subtract 6. So 7 minus 6 is 1. 1 minus 6 is negative 5. And negative 5 minus 6 is negative 11. If you keep going, which makes that a D, or a common difference, of negative 6. If you keep going, negative 11 minus 6 is negative 17. Negative 17 minus 6 is negative 23. And negative 23 minus 6 is negative 29. That one's pretty easy. It normally is whenever we're talking about arithmetic sequences. It gets a little bit more tricky whenever we're talking about geometric sequences. This one, if you did not figure it out, is a geometric sequence with a common ratio of 1 over 2. Now remember, we're multiplying by fractions, which is the same as dividing. So if you go to the front, we rewrote all the numbers, first with 40, then 20, then 10, then 5. And this is what I did. I tried to figure out how to get from 40 to 20. I know that 40 is half of 20. So if I divided it by 2, I'd get 20. Now, instead of dividing by 2, I made it into a fraction. In order to make dividing by 2 into a fraction, I put the 2 on the bottom, and then I put the holding place of 1 on the top. That's how I got multiply by 1 over 2. So 40 times 1 over 2 is 20. It's the same as divided by 2. 20 times 1 over 2 is 10. Again, the same as divided by 2. 10 times 1 over 2 is 5. 5 times 1 over 2, to get the fifth one, is 2.5. 2.5 times 1 over 2 is 1.25. And 1.25 times 1 over 2 is 0.625. Once you get all of that situated, please make sure that you have written your common ratio as 1/2. Again, same as divided by 2. And you got your arithmetic sequence down as D of negative 6. Once you have all of that, go ahead and turn your paper over and we can get started on the back. Now on the back of our paper, we get a little bit more specific into formulas. They're called recursive defined sequences. The first one I want to look at is the arithmetic sequence. Remember, this is when we are adding things. We are adding things. Now, I'm going to tell you how this formula sounds, but I do not actually care that you know how to say it. I just want you to remember how to do it. So this is called A of n equals A sub n minus 1 plus D. What is super important about this is the plus D. When we have arithmetic sequences, we are adding the number at the end. Now, what are we adding it to, may you ask? We're adding it to A sub 1. This is the number that you begin with. That is the first number in the sequence. That number is usually given to you, and then you go from there. All right, so let's look at right underneath it. It says a sequence can be generated by using A sub n equals A sub n minus 1 plus 3, where A of 1 is negative 3. Now, what all of that told me is that A of 1, which is this right here, is equal to negative 3. That is where we begin. That's our first number in our sequence. And from there, we are going to add 3 to it every single time. Now, I'm going to write this a little bit differently. I'm going to write it in a chart because it's much easier for me to figure out what my next steps are and then write it in the formal language. So I'm going to write a chart just like this. It says, what are the first 4 numbers in the sequence? Well, it gave me my first number in this sequence is -3. So I need to know what the second, third, and fourth number are going to be in the sequence. Well, if it's telling me that I am going to add 3 to -3 to get my next number, -3 plus 3 is 0. And then I'm going to use that same sequence to get my next number. 0 plus 3 is 3. And then my next number plus 3, 3 plus 3 is 6. Now I have the first 4 numbers in my sequence. Now I can write it in the formal language that it's asking me to write it. So like we saw before, we're going to write A sub 1 is what it told us right here is -3. A sub 2 is 0. We got that from right here. A sub 3 is 3. And A sub 4 is 6. Now, normally you write it in a straight line, but Miss Jackson writes really big, so you do what's best for you on your paper, as long as you understand that that is the formal language that it's asking you to write it in. All right? Now let's look at geometric sequences. Again, for geometric sequences, we are multiplying. So it says A sub n equals R times A sub n minus 1. The important thing that we're looking at here is our R value. This is the number that we are going to multiply. Ooh, it would help if I could spell today. We're going to multiply by this number. And remember, we always start with our A sub 1. That is our first term in the system. So it says, for this example, a sequence can be generated by using A sub n equals 5A sub n minus 1, where A of 1 equals 8. That tells me that I start at 8, and I am going to multiply by 5 because 5 is right in front of my A. Remember, in math, our numbers that are smashed right next to letters mean that we're multiplying by them. Sometimes you'll see a little dot in between. This time, they didn't. They were being lazy mathematicians, and that is okay. We can always be lazy mathematicians as long as we know what those things mean. Okay? Now, this time it's asking for the first 4 terms in the sequence. So we're going to draw a chart again, starting with our first term of 8. Remember that we got this 8 right here. So first term is 8, and it says that we are going to multiply by 5. Well, 8 times 5 is 40. And then we're going to get our third term by saying 40 times 5. 40 times 5 is 200. And to get our final term, remember, we have to have a common ratio. So we're going to multiply that 200 by 5 and get 1,000. Now we're going to write our common ratio of A of 1 equals 8. A sub 2 equals 40. A sub 3 equals 200. And A sub 4 equals 1,000. If you write it like this, remember to put your commas in between. That is how that they would write it in formal presentation. Now we have 2 more examples for you. I'm going to pause my video right here, and I want you to work these 2 on your own. And then when you're finished, come back and check your answer. Here's the answer for your arithmetic. And here's the answer for your geometric sequence. Now we do have 2 more questions, but I want you to go ahead and go in Google Classroom and look at the notes posted there for you. If you have any more questions, please let me know.